Hello, U3D7. So we're looking at probability and we're going to look at permutations, and then tomorrow we're going to look at combinations, and then we're pretty much done. So permutations with probability, the key to this is permutations. Don't forget that order is important, or order matters. And so these are the P questions. Remember those, right? So the P questions. So and PR as opposed to C. Now C questions are coming up tomorrow. In general, we just want to use our brains and work this out. Okay. So in general, also when we're looking at the probability of something happening, what you want to do is look at the probability of success, number of ways A can happen over the total number of outcomes, or success, the number of ways you get success over the total number of um, of outcomes. Okay, so you look at success, and again, success is whatever you define it as. There's no good, bad type thing. It just what we're looking for. Anyway, so the first few questions I set them up this way, where we're looking for the denominator as the total number of outcomes here. And to do that, for the second, what I do here is I don't ask the probability question until second. So we have a little practice of our permutations, and then we use that. So whatever we find up here is going to be the denominator of our question down here. Okay, so how many ways can we select a president and a vice president out of 11 people? So a bunch of ways to look at this. One is just to say, let's choose the president. Let's choose the vice president, right? Another is to say, let's do this. I have 11 people. I want to choose 2 from there. Okay, in a permutation, so that's 11 factorial over 9 and 2. No matter how you do it, as long as you don't do it that way, you get 100 and, or sorry, okay, don't forget, sorry, I messed it up. It's a P question, so it's this number and then this subtract that. You do not add this on the bottom. So that was a C question. If it was C11-2, which is not, or order doesn't matter, you need to get rid of the ordering and you divide by the 2 also, but because it's a P question, you don't. So the answer is 110. And then you're going to be asked questions like this. What is the probability that Jesse is the president? Well, if Jesse's the president, what you might want to do right away is say, Jesse's the president, I'm done. Okay? There's one way Jesse can be president, but no, there's more than one way for Jesse to be president, because you got to ask yourself this. If Jesse's the president, how many different ways can Jesse be president with different vice presidents? Well, very simply, if she's the president, or he, then there are 10 other choices for the vice president. So the answer is just 10 over 110. Okay. Another way to look at it is to say, I need to choose from the 10 people, one person. Okay. And no matter how you do that, you get 10. And 10 is your numerator. So that goes there. So the number of ways to success. Success is Jesse as president over the total number of outcomes, which is what we find above here. Okay, let's look at this one here. You have 5 salad options, 9 main course options, and 2 desserts. I don't know if that's spelled right. I gotta admit. Okay. I think it's 2 S's. Deserts. I don't know. Whatever. 2 desserts, and you want to figure out how many can you choose from there. That's 45, and times 2 is 90. You just multiply right across, right? Now you could go 5p1 times 9p1 times 2p1 if you want. You get the same thing, 90. And what's the probability that you don't like your meal if you do not like garden salad with tuna as your main course? So look at this now. Okay, let's go slowly through this. If I had my salad, my main, and my dessert, if I know that I'm choosing a garden salad, I already chose it, and I choose as my dessert as my main a tuna, I already chose it. So I only have one option for this and this, but I still have 2 options for my dessert. So the answer is 2 over 90. So you're not going to like this meal. You're not going to like garden salad, tuna, and one dessert, and you're not going to like garden salad, tuna, and the other dessert. So you got to count them both. So it's 2 over 90. Okay, and then change that to a decimal if you like. Okay, you should change it to decimal. Anyway, I'm not going to, but you don't have to. How many different combinations are possible if a 6-sided die, so you get a normal die, is rolled in a 4-sided die? So simply you just multiply the 2 of them, 6 times that, and then what's the probability of rolling doubles in this situation? Just go through it. Make sure you don't say, well, there's 6 double sets here, because if you have a 4-sided die, which we looked at, I think we may have looked at it. It's like a triangle, a pyramid. Right. You get 4 triangles put together. It's anyway, you get 4 different options. The only way you can get doubles is 1, 1, 2, 2, 3, 3, and 4, 4. So in total, there are 4 ways to get doubles, and 4 over 24. Success is doubles. 24 is total number of rolls. Let's keep going. How many license plates can you do this with 4 letters and 2 numbers? Repetition is possible. So for each letter, you have 26 options. For each number, you have 10 options. So whatever that is that answer. And what is the probability that the plate will contain exactly 1 vowel? Well, probability we're going to figure this out in a second, but the denominator is going to be the total number of plate options, which is this on the bottom. So you're going to keep that on the bottom. You can also rewrite this as 26 to the 4 times 10 squared, the same thing. Okay, and that's going to be your denominator. But let's figure out what the numerator is now. So again, it just, when you have a question like this, you might have to count two different ways, the top and the bottom of the fraction. But remember, you're looking for something on the top, and then you divide by the total number on the bottom. Okay, so the probability that the plate will. So before, if I said how many different ways can you have a plate that has exactly one vowel, that's your numerator, right? And then it becomes a probability because we're randomly choosing this we're putting this on the bottom and randomly choosing this. Okay. Again, everything is randomly chosen. I didn't add that every time. I thought about that later. I should add this to the question. If you select everything by random, blah, blah, blah. Okay. But anyway, think about this for a second. If you have one vowel, how many ways can you do this? Well, the numbers are still the same. So we know that. Okay. So 26 and 10 and 10. Let's assume repetition is still possible, okay, except you can't repeat if you have exactly one vowel. So basically there are 5 vowels. We don't count Y because we don't put up with that. Choose one or the other Y, okay, and since you didn't choose, you're not a vowel. So there are 5 vowels, so you have to choose which vowel, okay? So ask yourself which vowel you're going to choose, right? So 5 options there, and then you're going to have 21 options for the other letters, the non-vowel letters, consonant letters. So 5, 21, 21, 21. Now, relax, okay? You're probably freaking out here because this is saying you're choosing your vowel essentially for the first letter, right? So you can choose, it can go vowel, consonant, 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 or you can go consonant, vowel, consonant, etc., and move this vowel around. So there are 4 different options where the vowel goes. So you need to multiply the whole thing by 4. Okay, where you put that 4 is up to you. So 5 options for which vowel, 4 options for where it goes, and then 21 options for the other 3 letters. And then the numbers are still the same. So that's your numerator. Your denominator is there also. Okay. How many ways can 8 friends stand in a line? Remember this? 8 friends. Order matters. What's the probability that Phil sits at an end? So we did this a bunch of times. Phil can be here or here at the end, and there's people in the middle here. So we look at this one first, where Phil's first. There's 7 factorial ways to line that up. Phil's last, there's 7 factorial ways to line that up. So you can add those together, which is the same as 2 times 7 factorial. Okay, what are the odds of this happening? So this is the probability. So the probability would be this over this, right? And what's that? 1/828. So this is going to be 0.25 actually. That's 25%. Okay, so this works out well because what are the odds for this happening? This is the probability of Phil at the end. So I'll call this PE. Okay, the probability of Phil not at the end is going to be the complement of this, or 1 subtract 0.25, which is 0.75. Okay, so what are the odds for this happening? Remember, with odds, what you're going to do is the probability of something happening as a ratio to the probability of it not happening. Okay, that's for the odds of this happening. If the odds against this happening, you'd flip these backwards. Okay, and then you just go through it and set these up like this. And what I do is multiply by 100 first, and then write in lowest terms. And you might have been able to do this a little quicker. But there we go, 1 to 3. So it's a 1 to 3 odds that happens. Okay, next up, let's keep going. How many ways can these friends sit in a circle? There were 8 friends, I believe. So it's 8 minus 1, 7 factorial ways to sit in a circle. In the circle, how many ways can Rich and Kim sit beside each other? Remember this, when Rich and Kim want to sit beside each other, we line them up. Okay, so there's 2 ways to line them up, or 2 factorial ways to line them up. And then they become an entity. So now you basically are lining up 7 things in a circle. I guess not lining up, but putting 7 things in a circle. So, 7 things in a circle. So that will be 6 factorial. So that whole thing is over this. So this is the bottom. This is success. Find out what that is, and there's your answer. Oh, let me do this. What's the probability that you select a 7 and then 2 aces when you draw 3 cards in a row? So this one here, we'll go straight into it. So you're drawing 3 cards in a row. So the denominator, is 52 options for the first one, 51 and 50. Or order mattering. Order matters here. So another way to look at this is 52 P3. Okay, so you 52 options, 51, 50. And then what you're doing is you're choosing a 7 and then 2 aces. So how many options do you have for a 7? 4 different options, depending on the suit. And then for the first ace, you have 4 options. And then for the second ace, since you've chosen an ace already, you have 3. So there are 4 times 4 times 3 different ways to go 7 ace ace. and then as a probability, you just divide these out. Now, some of your answers, guys, I know I've been saying round to the nearest, like the nearest hundredth or the nearest percent. Some of your answers will be less than that, right? So I'm not sure what this one is exactly, but a lot of times you're going to get a lot lower numbers. So just be aware of that, right? If you've been rounding the whole time, you're going to be rounding a lot to 0.00 or 0.01. Okay, so just be aware that these questions here, you're going to have to change the standard of how we do this, okay? And the birthday question, that's a great question on page 92. We'll talk about that in class. Okay, hope that was good. And any questions, just